Okay guys, in this video we're going to be targeting a certain type of measurement called a bearing when it comes to solving triangular application type situations or solving triangles. So in this problem here I want to read through it with you first, and then we're going to talk about this idea of what a bearing is. And so it says locating a fire. The bearing, okay, let me get my pen tool working here. The bearing from Pine Knob Fire Tower to Colt Station Fire Tower is, and we would read this as north 65 degrees east. And so as you look down here, we can see our Pine Knob Tower, our Colt Station Tower. But it says that our direction from Pine Knob to Colt Station is north and then 65 degrees towards the east. And so we can see this kind of measurement north and then 65-degree east deviation here. It says and the two towers are 30 kilometers apart. So you can see that they put this 30-kilometer measurement between them. Also, they say that a fire is spotted by the rangers in each tower, and here's our fire over here. But basically, it's going to have a different bearing from each tower to that fire. So notice that it mentions that it has a bearing of north 80 degrees east from Pine Knob. So that is to say, if the fire is here from Pine Knob, then if we go north and then head 80 degrees towards the east, that's the direction we're heading in. And it says south 70 degrees east from Colt Station. So you notice from Colt Station, they drop a line south, and they deviate 70 degrees towards the east to go in the direction of this fire right here. So our job is going to be to find the distance of the fire from each tower, but those distances really would be these two side lengths on our triangle right there and there. So it's unmistakable that we have this obtuse triangle right here and that we want to go find some side lengths, but it's all going to be contingent upon, could you tell me some angles on the inside of this in the first place? And so basically we're going to have to understand this bearing business. And so when we talk about a bearing, we say, what is a bearing? You know, we notice some things about these bearings up here. First of all, a bearing gives a primary direction, either north or south. And so that is to say that on any of these directions that we saw up here, it says start north or start south. And then what it does is it gives us an angle next. So it also gives an angle towards, well, let's put it this way, an angle between 0 degrees and 90 degrees, and tells you to deviate that far either east or west. And so this idea of a bearing in many instances is just the idea that I'm going to start you north or south and I want you to deviate either towards the east or to the west. So as an example here, whoops, let me get out of this. As an example here, okay, if I were to write an example of a bearing, we could say north 15 degrees towards the west. Well, what we do is we tend to put this imaginary crisscross through here where this is north and this is south. And we usually make north and south quite long. But if I were to say north 15 degrees west, this truly would mean start north and then we're going to head towards the west 15 degrees. So if I had to sketch this, the way it would look is just kind of like you see it right here. And I would have to put 15 degrees because I started north and went 15 degrees towards the west. You could see that this would be a really effective measurement tool for just about any direction, because we could always reach any direction using this scheme. And so going back and looking at this situation over here, the idea was to find either of these measurements that you see on either of these sides. So to make our job a little bit easier, what I'm going to do is I'm going to label out our vertices here, A, B, and C capital. So this is going to be lowercase c, this is going to be lowercase a, and this is going to be lowercase b. But I think the idea is we want to find the values of A and C. So using the directions that we were given initially, could we figure out what these interior angles are on this triangle? And so the answer certainly is yes. I want to start kind of over here at Pine Knob and try to find this angle right here. So because we were told that from Pine Knob to Colt Station we went north and 65 degrees towards the east, but from Pine Knob to the fire we went north and 80 degrees east, then this difference in rotation right here is just really going to be 80 minus the 65. So we get a 15-degree angle right here. That one's probably the easiest of our three angles to go and determine. Now, over here, we already kind of have a partial angle at this 70. In order to find the rest of this, though, what we're going to do is we're going to borrow from a property of parallel lines. And that is to say that if we have two lines that are parallel, and they are cut by what we call a third line here called a transversal, then these angles that are on the alternate sides of this line on the interior here, we call these alternating interior angles, these would have to be congruent to one another. Likewise, these also would have to be congruent to one another, these two here. So looking at what we have here, what I'm always going to tell you is whenever you're using bearings, we're always going to make the north-south line through this a little bit longer than it needs to be, just because what I want you to witness is, if I wanted to find this angle right here, that it's really two parallel lines that are north-south being cut by a transversal here. And so if I wanted to find this angle right here, I would look at its alternate interior on the other side here, which in this case happens to be this 65. So now knowing that this is 65, the neat thing is that I could really tell you that this entire top angle is the 65 plus this 70 right here, which gives us 135. So at this point, what I'm actually going to do is I'm actually going to resketch this out here just because I feel like it's getting a little crowded. But I know that this is 15. We know that this top angle is 135. We have C, B, A, little c, and we know that little b is 30 excuse me, kilometers. Okay, so using what we know about these top two angles here, this is 135. It just doesn't look good. Let me try to fix this here. There we go, that's a little better. Then we could add the two angles up that we know. We say 15 plus 135 is 150, and if we take that away from 180, okay, then what we're going to get left with is our third angle here, 30 degrees. So essentially, this problem is now set up so that we do have some side angle pair action going on, and we can use the law of sines, but we'll set up our side angle pair with our 30 over sine 30, and then do the same thing with our a over sine of 15 here, or maybe our c over the sine 135 to solve the rest of this. So I'll leave the solving of this up to you now that we can use the law of sines, but I did want to mention that this is how we use our bearings, and that when you do work with bearings, put your north-south lines so that they're a little bit longer than they need to be, because we're going to interpret these sides of this triangle as being transversals that cut those north-south lines, and that's going to be more easily able, or make it more able for us to find those angles more easily. Okay, cheers.